Alright, hello, and welcome to our notes over forces at angles. A couple things before we get started on this. First of all, I strongly suggest, as you are listening along to this video, that you are taking notes. Do not just sit there and be a passive participant. Make sure you are actively writing down notes, summarizing the things I'm saying, ideally following along in the process. I am using the front page of your first set of problems to do these notes, but make sure you are following along and actively taking notes. If you are sitting there being a passive listener, you are not going to retain as much information as if you are actively note-taking. That goes for these notes and all notes in all of your classes. Being a passive participant is not going to be as beneficial for your ability to retain information, especially in a class like physics where we are not looking to just regurgitate information, but we are looking to apply that information in new situations going forward. Active note-taking is going to do a lot to help with that. So as we're going through this, I'll give you a moment, get a sheet of paper, and be actively taking notes. I would even go as far as to say it is better to be physically writing them down rather than typing away on your Chromebooks. It's going to be better if you are physically writing. And again, we are looking to summarize information, summarize it. Don't necessarily try to verbatim write down every single thing I'm saying. All right, so forces at angles. This is a direct continuation from Newton's laws. So everything we did as part of Newton's laws still applies here. We are still looking to use F equals ma, specifically F net equals ma, in a lot of situations. It continues to be true that you are not going to be successful if you are trying to blindly do math. You do need to understand the physics of the situation and use that to help you set up your problems. As an example, one of the things you need to be looking for is what is the net force doing in each of these situations. And again, remember, when we're specifically looking at net force, we are looking for the influence on acceleration. If an object is accelerating in a specific direction, there is a net force in that direction. If an object is not accelerating, then there's not going to be a net force. The net force would be zero in that direction. As an example, if I am pulling a crate across the ground at an increasing rate, there's going to be a net force in the horizontal direction, in the x-axis. But if I'm just sliding that crate along the floor, it's not like it's flying up into the air or tumbling down into the center of the earth. It's not accelerating vertically. Yes, there is the acceleration due to gravity accelerating the crate downwards, but there's also that normal force acting against it. The crate isn't moving up and down. It's not accelerating up and down. So the net force vertically in the y-axis, that would be zero. That is information you need to be able to identify and use as you are setting up these problems. Especially now that we are introducing things at an angle, being able to evaluate those situations in the x and the y-axis and look at the physics of what's going on and being able to pull information out of that, that is a critical skill. So let's go ahead and get on into our introductory notes for forces at an angle now. So first things first, we are no longer having a force that is purely in one dimension. It is now in x and y. It is at an angle. Just like last time when we were doing 2D kinematics and we had things at angles, there were certain things we could do to those vectors to find their components. Specifically, their x and y components, just like it shows up here. I have my force at an angle. There's an x and a y component. The same exact information still applies now. This force vector here, it's kind of going to the right. It has an x component. It's also kind of moving upwards. It has a y component. Using trigonometry, I can figure out what that x and y component are using SOHCAHTOA. Or more specifically, sine and cosine in this case. So, one of the first things we are going to want to do is go to our handy little calculators here, and let's turn off this LED. And I'm going to want to make sure that my calculator is in the correct mode, first of all. So, as I can see, looking at my calculator, it says I am in radians. That is a problem. I do not want to be in radians. I need to be in degree mode. So what I'm going to do is I am going to hit the math button on the calculator. Sorry, not math. The mode button on the calculator. Right here, I'm going to hit that mode button. It's going to pop up a new menu. You can see down here, says radian that is highlighted. I want to go down and highlight degree mode, or degree here. Hit enter, hit clear, and now it says degree at the top. I am now in the right mode. If your calculator's in the wrong mode, you're going to be wrong no matter what you do. So make sure you switch it to degrees. Alrighty then. So now that I have done that, I'm going to need to break this guy apart into their X and Y components. This being on my free body diagram is not very useful. My free body diagram, which we will get to, has to only include information that is either horizontal to the right or vertical up or down and left, respectively. It cannot have things that are at an angle like this. It's going to complicate things. So I would strongly suggest whenever you see or are told there is a force at an angle, you go off to the side on its own and draw your triangle separately to get Fx and Fy. This is the only time this force is going to be used. The force at an angle, this 750 newtons for this one, it is only going to be used at the very beginning and only to find the X and Y components. Never again in the question. This only gets used once. So let's use this one as an example and break it into its X and Y components, and then we will go ahead and draw our free body diagram. Alright, so first of all, I have my 750 newtons here at this angle. It tells me it is at an angle of 27.9 degrees. 27.9 degrees. And I will do a dotted line for my Fx and a dotted line for my Fy. So I need to find Fx and Fy. And again, we are going to do this using the sides of our triangles, but it's a little more consistent now. So this is the hypotenuse side of my triangle. The x component, is my adjacent side. The Fy is the opposite side. Again, as a refresher, the opposite side is the easier side to find first. It is the side that is opposite your angle. My angle is here on the left side. I go to the right side. Here is my opposite. The other one down here has to be the adjacent. The longest side, the diagonal, that is your hypotenuse. So, if I am looking for my Fx here, that is going to be me using cosine, because that is the function that goes with adjacent and hypotenuse. As a reminder, SOHCAHTOA. SOHCAHTOA. Sine is opposite and hypotenuse. Cosine is adjacent and hypotenuse. Tangent is opposite and adjacent. SOHCAHTOA. In this case, this is my adjacent, this is my hypotenuse. I'm going to use cosine. But before we go ahead and start doing math, I have already split this into its x and y component. Let me go ahead and make my free body diagram first. Again, I don't want to put this diagonal one on my free body. That's going to mess me up. I only want to be dealing with things here that are going to be only in one dimension. So only up, only down, only right, or only left. So first of all, I have my Fx and my Fy. I can draw those in. My Fx is to the right, so Fx right there. I'm also going to have Fy going up. Because it was going up over here, it's going up over here. So there's my Fx and my Fy. Now I'm going to want to look for what other forces there might be. It tells me it is accelerating to the right. So I know that I'm going to have a net force going to the right. I will tell you, looking at the question here, we've modified this one a little bit. There will be friction here. So there is going to be friction to the back. How do I know there's going to be friction to the back? I know that because, if we're being perfectly honest, this used to be friction at angles, and we have modified it this year to do forces at an angle first. There used to be extra information here telling us that there was going to be friction. I have erased that. Do just know that in every other situation down here, it tells you that there's friction. This is not something that you need to magically know is here. In fact, the answer is given to you down here for friction. But just know that in this situation, there used to be information here saying there was friction. There no longer is, but I am here telling you, yes, there is friction. And that every other situation on here tells you that there is friction. Or you're looking for the friction. All right. So, I've got friction going backwards. I do also have forces in the vertical. As always, I have my force of gravity, my Fg going down, and if this is sliding along the ground, which it presumably is, that does mean there is going to be a normal force, an Fn. Please note, Fn is not the same thing as Fy. These are different forces. Fn is the result of the object being on a surface. Fy is the result of me applying a force upwards at an angle. I have an Fy and an Fn in this case. That is going to be important information later. But there is my free body diagram. So once I have my free body diagram at this point, I am free to start solving for the information I need. I could find fx, I could find fy, and then if I was doing a word problem, like down here, which we will do in a minute, I am free to start solving for whatever I need. However, in this first example here, we have this broken apart into parts, so that you will find each part of this process on its own. This is generally the order they are done in, but it is not necessarily always the order they are done in. It depends on the situation. One of the things you pretty much can always do first is you can always break this apart into its fx and its fy if you have forces at an angle. And that's the first two options here. Fx, Fy, those are the first things we're looking for. So, let's finally go ahead and start doing that. In order for me to find Fx, like we were talking about earlier, that is my adjacent component. I have the hypotenuse, adjacent and hypotenuse, that's going to be my cosine function here. I can go ahead and do that. So, cosine of my angle is going to be equaling my adjacent over my hypotenuse, which in this case, this is, my adjacent is Fx, my hypotenuse is 750 newtons. If I multiply the hypotenuse to the other side, that'll give me what I'm looking for. So what I end up with is, essentially, F cosine angle equals Fx, like that. But if I plug my numbers in, I end up with 750 cosine of my angle, which was 27.9, equals my answer. So let's go ahead and do that real quick. 750 cosine of 27.9, like that. There is my fx, 662.82. 662.82. There is my first answer. Next thing it wants me to find, that is Fy. That is my opposite side of the triangle. Opposite and hypotenuse, that would be sine. It's going to be the same format as this, but instead of F cosine, it's going to be F sine. This would be F sine of the angle equals Fy in this case. F sine theta equals Fy. This force is going to be my force at an angle again, which is again 750. So this is going to be 750 newtons times sine of 27.9. And that's going to equal my answer. So 750 sine 27.9, 350.94. 350.94. There is my Fy. So again, we have found Fx and Fy by using our trig. We used cosine for x, we used sine for y. Again, this is stuff we have done before. Same exact process. Alright, so I found those two easily enough. Next thing it wants me to find is Fg. Fg is another one of those ones that's very easy to find. It has its own formula. It is on your formula chart. If I grab that right here, the weight formula. Again, as a reminder, weight and force of gravity are the same exact thing. So Fg equals mg. There's my formula. So this is just going to be Fg equals m times g. The mass I already have, it's up here, 225. So this is going to be 225 multiplied by 9.81, and that's going to give me my answer here. So if I do that, 225 times 9.81, that gives me 2207.25 newtons. There we go. All right, Fg, same exact thing as before. N for normal force. This is where things are a little bit different. Since we are solving for the normal force, in the past, it has usually either been Fn is the same thing as Fg, or if we're accelerating up and down, if we're on an elevator or something, they're not the same. They are no longer going to be the same any point. Why is that the case? Here's the thing. I will use a little sheet of note card for this. When we are solving for the normal force, let's take a normal situation here. Like this, acceleration equals 0. Okay, if my acceleration is 0, that means my Fnet equals 0. And if my Fnet equals 0, then when I go to make my formula, when I make my Fnet formula for my free body diagram, which again, as a second reminder, Fnet is everything going right minus everything going left, or it is Fnet equals everything going up minus everything going down. In this case, we're using this one. My formula, Fnet is 0, so I have 0 equals Fn minus Fg. If I add Fg to the other side, I get Fg equals Fn. This is for a situation where I have acceleration being 0 like this. If I take the same situation, but this time I have something that looks like this. I have Fn, I have Fy, I have Fg. If I do the same thing, acceleration equals 0, I end up with Fnet, which equals 0. I get 0 equals Fn plus Fy minus Fg. Where did that come from? Again, as a reminder, my formula, Fnet is everything going up minus everything going down. That means if I have multiple things going up, like here, I have to add them together. My stuff going up is Fn plus Fy, because both of these are pointing upwards, minus Fg. So when I go ahead and add Fg to the other side, I no longer have Fg equals Fn. I now get Fg equals Fn plus Fy, which, if we're looking at the physics of this, should make sense. If I am not accelerating vertically, if I am pulling a box sideways along the ground, if it's not accelerating up or down, then that means the vertical forces up and down have to be balanced. My net force is 0. If my net force is 0, that means my forces are balanced. That means everything pointing up equals everything pointing down. That means Fn plus Fy has to equal Fg. Fg equals Fn plus Fy. If instead I was pushing down on the object, let's get another note card here. If I was pushing down, I had this instead. Fg, Fy, Fn. If I'm pushing downwards, my formula, again, A equals 0, F net equals 0. I end up with 0 equals Fn minus Fg plus Fy. Why is Fy over here now? Because it's pointing downwards. If I was pushing down on the object, if instead of being up at an angle like this, if I was instead pushing down at an angle like that, then my Fy ends up pointing down instead, and it gets added onto Fg. I end up with Fg plus Fy equals Fn. I end up with a little bit of a different formula depending on if Fg is pointing up or down. But the main thing to point out here is, in either case, if I'm not accelerating and I have another force included somewhere, it is not Fg equals Fn. It is Fg is Fn plus Fy, or Fg plus Fy equals Fn in these situations. And on some level, that should make some kind of sense. I want you to think about for a second anytime if you've had to move furniture. Ideally, if you try to think about which of these two options are going to be easier, would you rather pull up on a piece of furniture or push down on a piece of furniture? Normally, if you're moving furniture, you're going to lift it off the ground. It's going to make it move easier to the side. Part of the reason for that is when you are lifting upwards, the normal force isn't going to be as high, and that makes moving the object easier. This is going to be something that we're going to talk about at length when we start talking about friction, because that's going to be a very big deal at that point. So I want you to keep that into the back of your mind. Whether or not we have something going up or down affects our normal force, and that affects how easy it is for something to move. Again, that's not something strictly for right now, but that's going to be important later. Alright, so now I know when I am looking for Fn, I have to check and see what my formula is going to look like. In this case, because I am going up and to the right, I know it's going to look a lot more like this. This is my formula I'm going to use in this case. Fg equals Fn plus Fy, because they're both pointing up, which is exactly what I have here in my free body diagram. Fn plus Fy equals Fg, because if this is accelerating to the right and not up at an angle to the right, I know my net force up and down has to be 0. So my formula here, Fg equals Fn plus Fy. If I am solving for Fn, I'm going to have to subtract Fy to the other side. So that's going to give me Fg minus Fy equals Fn. That's what I'm going to go ahead and do here. Fg minus Fy equals Fn. My Fg is 2207. So 2207.25 minus my Fy, which was 350.94. 350.94 equals whatever my answer is going to be. So let's do that. 2207.25 minus 350.94 equals, there is my Fn, 1856.31. It is smaller than my Fg, which it should be. It should be smaller than my Fg. Why? Because the Fn isn't the only thing going up. Fn isn't having the sole responsibility of keeping Fg in check. Fy is contributing to that. They are working together to balance out Fg. That means Fn doesn't need to be as large because Fy is helping it. On the other hand, if we had this situation where Fy is going down, Fy is helping Fg, they're both going down, Fn would be larger because it's having to compensate not just for Fg pulling it down, but also Fy. There goes the meter stick. Alright, so that's my Fn. The force of friction has already been found for me, so I don't have to worry about that. And lastly, I am looking for my acceleration. So, how am I going to get my acceleration in this case? Well, the same way I would for anything else, really. I happen to know the mass in this case. I know that. I also could find a net force. I don't know my net force right now, but I could find it. So I am going to use good old trusty F net equals ma. And in this case, my net force, if I am accelerating to the right, my net force would be in the horizontal. So my net force is going to be everything going right minus everything going left. Again, I know that's where my net force is because net force and acceleration are in the same direction. If I am accelerating to the right, that means my net force is to the right. So Fx minus Ff will give me my net force. So I can come back down here, Fx minus Ff equals ma is my new formula. So if I go ahead and write that out over here, my Fx, if I go back to earlier, was 662.82 minus my Ff, which is 397.184, and that's going to equal my mass of 225 times A. So what do I do now? I'm going to subtract these two and then divide out my answer. And while I do this, I'm going to take this as an opportunity to show you a mistake you are probably making in the calculator. So if I just put this in directly, 662.82 minus 397.184 divided by 225 gives me an acceleration of 661. Now, a common thing you can do in this class, and it sounds very silly, is, but does that make sense? Does this crate accelerating at 661 meters per second make sense when my forces are relatively balanced? Not really. That wouldn't make a lot of sense. Realistically, if this friction wasn't here, my acceleration should be a lot larger than basically the same as the force. That's kind of weird. That doesn't make a lot of sense. The reason that doesn't work is because the calculator is doing exactly what you tell it to do, not what you think it's doing. It is going to follow order of operations, PEMDAS. It is going to do division first and then addition and subtraction. That is not what we want here to happen. How do I fix this? I use parentheses. So I'm going to put parentheses around the top half. Originally in my formula, I have these being subtracted from each other. That subtraction needs to be put in parentheses so the calculator knows, oh hey, these numbers go together. So I have to put them in parentheses. If I do that, I get a much more reasonable answer. About 1.18 meters per second squared. That's exactly what we were looking for. Acceleration equals 1.18 meters per second squared. As for what makes sense and what doesn't make sense for a spot check, that comes with experience from solving different types of questions and seeing what the trends are. And just general physics knowledge. That can sometimes tell you, like, hey, that looks like a weird number. That might not be right. I'm accelerating something that's very heavy. 225 kilograms is a lot. 600 newtons, that's not a lot of force compared to the mass. It probably isn't going to be accelerating at nearly a half kilometer per second. That wouldn't make sense. That's really fast. Something like this, that makes a lot more sense. It's not going to accelerate a lot. That's not a lot. Probably good. Something else you can do in the calculator, if you don't like using the parentheses, you can also use the fraction bars. If I hit this green alpha button right here, if I hit the green button, and then I hit the y equals button, it pops up this little menu. If I hit 1 or enter, it gives me a fraction bar. If I then do 662.82 minus 397.184, and then I am dividing in the denominator by 225, oh hey look, it's the same number, because that's the actual order of operations we want. Be very careful with that. Alright. those are all the steps you need to solve these kinds of questions. I am going to leave the rest of them there for you. You have this to come back and reference. One thing I do want to note, and I will start the next one for you, is, again, you can't math your way through a lot of these questions. You really need to be paying attention to the physics of what's going on and the process of how do I set up this specific question. Every question could be set up a little bit differently depending on the scenario. You can't blindly just try to memorize one catch-all solution. You're going to have to learn the process. So, how would that look like? For the most part, in this type of a word problem where it's just looking for one answer and not all the individual little parts, you want to start by trying to find a formula that has what you are looking for in it. Then you go down the process of writing down your knowns and unknowns, drawing a free body, all those other things. So let's look at this first question here and see what it actually wants and see if we can set up a question. So I have a boy pulling a crate with a rope. It's making an angle of 28 degrees to the horizontal, so it's going up. The friction of the crate of the deck it gives me is right there. It's exerting this kind of a force. Remember, he is exerting this force at an angle. This force is at an angle. I want to find a couple things. I want to find the normal force on the crate and then the acceleration of the crate. Alright, so if I'm looking for the normal force first, I'm probably going to want to pick a formula that has normal force in it. Now, remember, unless the formula is on your formula sheet, you're going to have to use your free body diagram. Normal force does not have its own formula, so I don't have a way to find it here. There is the friction formula that does have normal force in it, but we haven't talked about this yet, so you can't use that yet. I also don't know the friction. Well, I do in this case. If I knew that, it would help, but there's other stuff. Anyways, I digress. That is next time. Since I cannot use the friction formula here, there is no other formula I can use. My only option is to go ahead and use my free body diagram. Okay, just like I would do here. I don't have a free body diagram yet. I'm going to want to make a free body diagram. So we're going to speed run this real quick. I have a force at an angle here. It's going vertically like that. How do I know it's going vertically? Because that is a positive angle here. It is an angle to the horizontal. It is a positive angle. If my horizontal, if I go up here, if that's my horizontal and it is a positive angle, there you go. It is above the horizontal. If it was said below the horizontal, which some of them do, then it would be below like this. It depends on the situation. Anyways, in this case, it is above the horizontal, so I have a positive fx, I have a positive fy. That means my y will be pointing up, and my x will be pointing to the right. So when I draw my free body, I've got my crate here, I've got fx, I've got fy, I've got fn, I have friction, it's going to oppose the motion, so it's going to be backwards, that's going to be ff, and I have fg. There's my free body. Where is fn? Fn is in the vertical, so I'm going to want to be looking in the vertical. And again, because it doesn't have its own formula, I'm going to have to get it from my free body diagram, which again is these guys. Everything in one direction minus everything in the other direction. In this case, it's everything pointing up minus everything pointing down. My fy is pointing up, so I'm going to do fnet in the vertical axis. Fnet equals, that's t, everything pointing up. That is fn plus fy, fn plus fy minus fg. There's my formula. At this point, I would want to start plugging in things and solving. However, here's the problem. I don't know what a lot of this is. There's some things I do know. For example, I do know my net force in this case. This is accelerating to the right. He's sliding it to the right, not up or down. So it's not accelerating up or down. So I know this Fnet in the vertical axis. And again, I got to stress, you need to be paying attention to where is this Fnet. Since it is in the vertical, it's going to stay in the vertical. So, because it's not accelerating up and down, that means There's no acceleration. No acceleration means no net force. So my net force in the vertical is 0. So I know that. Great. Cool. Got that one. My normal force, that is what I am solving for. I don't know that. That's okay. Fy, I don't know my Fy. I'm going to have to find my Fy. I would need to write a formula for my Fy. In this case, I would get it from using SOHCAHTOA, using my trig. I'd want to set up my little guy over here, find Fx and Fy. Though again, if we remember from earlier, to find Fy, that is F sine theta. F being the applied force at an angle. So this would be my F sine theta equals Fy. So I could solve this to get my answer for Fy, and then I have that. Great. I also don't have Fg, but I could find Fg. Fg does have its own formula. This is Fg equals mg. So I could go ahead and find that. Once I've found both of these, I can plug them into here and then solve what I am looking for. This is one of the common things going forward, is in your formulas, if you are missing things, you have other ways of finding them. You would want to use that formula to find the missing thing. I find using a system like this, where I write out the formula first that I'm trying to use, go through and check every single part. Do I know this? Great. Wonderful. Do I know this? No, but that's what I'm looking for. That's not a big deal. But I don't know either of these. I would need to know both of these to solve this formula. Because I don't know them, I need to find them. So I need to find a new formula for each of these. The way I find Fy is with this formula, F sine theta. The way I find Fg is with this formula, the weight formula. I would then go through and solve for these things, get my answer, and then plug them back in where I need them, and then I can go back and solve what I am looking for. This kind of a process where we are breaking things apart is very important. Again, you can't necessarily just math your way through all of this. Well, can I just brute force it and find everything like this? Technically, yeah, you could, but this is going to be more work and possibly more confusing than learning the process of, okay, what am I looking for? I'm looking for the normal force. The normal force would come from my free body diagram. The normal force is in the vertical, so I'm going to look in the vertical. That means I'm going to use my F net equals everything pointing up minus everything pointing down. That would be like this. F net equals Fn plus Fy, because they're both up, they get added together, minus everything going down, which is just Fg. So I have this formula. Okay, I know F net, it's 0. I don't know Fn, but I'm looking for it. But I don't know either of these things. Because I don't know them, I need to find a formula for them. And hey, I remember that F sine theta gives me Fy from doing this earlier in the problem up here. I also remember, because we've done it a lot, that if I need to find the weight of something, that's just the weight formula on my formula sheet, which again is right here, this guy. That process is a lot easier to learn than trying to brute force every possible thing and just hope and pray that you can like remember what goes where and what you need to find. This is a defined process. It is a defined structure, scaffolding, to help you find your answer. This is something I would strongly advise doing. So, over the weekend, I will post a second video of me going through the rest of these. That will probably go up... No, that'll probably go up Monday. I'll wait for... Yeah. That'll probably go up Monday. But if you're in the future or on B-Day, it'll probably already be there. So, do what you can for now. And if you are stuck and fully stuck, come back when I send out the Canvas announcement, or if this is in the far future, it's already linked on Canvas. Anyways, that is our somewhat lengthy introduction to forces at angles. I hope you find this useful. If there are parts where you feel like, hey, Mr. G, I don't feel like you explained that part well enough, I need you to tell me that. I cannot read your minds. If you think there's a part that needs to be explained better, please tell me. For those of you that actually made it this far and watched it, thank you. Yeah, that's kind of all I got. I hope you all are having a good day. Again, I can't read your minds. Please let me know when you have questions. If something doesn't make 100% sense, you gotta ask. Or come to tutorials and ask me then. Whatever. Alright, I hope you all have a wonderful rest of your days, and yeah.